Hey everyone, it's Mr. Canfield. This is part 2 of the BC Review Guide. So here we go. Part C says, is my lighting okay? Yeah, okay. Sorry. Part C says, use P of x to find an approximation for the y-intercept of f. Is there enough information to determine whether f has a critical point along the y-axis? If not, explain why not. If so, determine whether the critical point is a relative maximum, relative min, or neither, and justify your answer. So, if you recall from last time, or maybe for you from 2 seconds ago, our P of x, oh, it's at the top. I'm silly. Sorry. So our P of x is up here. Sorry, I was getting my work. I've already done this. I just am, I deleted it because I fumbled over my words, like I'm doing now. So we want to find an approximation for the y-intercept, and our P of x is this thing. So, well, the y-intercept is when x is equal to 0. So all I have to do is plug in 0 for x here. So that's going to be 4 plus 3 times 0 plus 4 squared minus 0 plus 4. And remember, if we're trying to game the exam, if we're trying to do our best and show everything, things like this showing that I'm plugging in 0, really, really good step, because any arithmetic mistake that I make from here on out is so minor. Me showing that I understand what I'm doing is absolutely crucial. So let's see, I get 4 plus 16 times 3 is 48, and then that's 64. So like jumping to here is really dangerous on an AP exam. Let's see, so that's 52 minus 64. I got negative 12. So our approximate f of 0 is negative 12 according to our polynomial. So, is there enough information to determine whether f has a critical point along the y-axis when x is 0? We can say, is there enough information to determine anything about f along the y-axis? And the answer is not really. This is an approximation based off something that's 4 units away. You know, our approximation is for f of negative 4. That's really, really far away. Sorry. My phone changed orientations on me last time, and I had to go through a whole rigmarole to flip the video. So, yeah, my phone doesn't have enough space on its internal hard drive to allow me to flip a video, but the SD card can take hours of it. Yeah, it's an Android thing, but hey, I'll take the cheaper phone and the lower video quality. So let's get back to this. The fact that we're 4 units away, that says we really can't say anything accurately about x equals 0. So no, there's not enough information. And I looked this up on the AP, on the College Board, to find another AP question that looks very similar to this. And the language that they use is, it's not possible to determine if f has a critical point at x equals 0. It doesn't say it doesn't. It just says we don't know if it does or not. Because P of x only gives exact information at x equals negative 4. So I only know what's going on at x equals negative 4. Beyond that, we can't really say a whole lot. So, all right. D, the fourth derivative of f satisfies the inequality. All right, and when we see this, we should go, okay, this is going to be some kind of Lagrange error for all x in the interval negative 4 to 0. Let's see. Use the Lagrange error bound on the value of the y-intercept found in part C above to explain why the y-intercept must be negative. Okay, well, so we know that f of 0 is, we know p of 0 is negative 12. So if we were to take p of 0 and we add on our remainder at 0, as long as that's still negative, that's going to show us that this is negative. So we got to figure out what our remainder is. Well, remember that the remainder is equal to f of z, fourth derivative, times x plus 4 to the fourth over 4 factorial. So to pull in stuff from the previous video, remember that each successive term it has the next derivative of when x is negative 4, and then we have the x plus 4 to that power over that power factorial. So now that we're on the fourth derivative, we find the remainder by taking the next derivative. And the cool thing is it tells us, it says, hey, the next derivative, it's 11/10 or less. And with the remainder, the idea is we always want to be using the greatest value it can possibly be, or just, you know, hey, we know it can't go above this. It's an upper bound is the technical term for that, and I like to talk about it like it's a fence that we can't go past. So then it's, you know, whatever x value we're looking at plus 4 to the fourth over 4 factorial. So let's check this out. If we plug in our 0, we get 11/10 times 0 plus 4 to the fourth over 4 factorial. So I looked it up. This would be a calculator question. Thankfully, I don't really feel like doing this by hand because I'm lazy. I'm currently using my calculator as my counterbalance on my improvised tripod that I use. So I had to do a little. All right, let's see. There. TMI, I'm sure. And now you're probably like, wow, Canfield, I'm so glad that you haven't made a video for us before. These are terrible. All right, let's see. 4 factorial, we can go math. Factorial, all right, 11.73. Okay, so the maximum value, so R of X, 11.733, all right. So that's my remainder. So that's a pretty big error bound if we think about that. That's saying that f of 0, the true f of 0, is somewhere between -12 and -12 plus this error bound, and -12 minus this error bound. It's saying, hey, it's somewhere between those two numbers. So somewhere between -2. Oh, I should say, sorry, f of 0, true f of 0. F of 0, the true f of 0 is somewhere between these two numbers. That's what I meant to say. All right. So illegal to post this document on the internet. All right, so the true f of 0 is somewhere between, I mean, this is irrelevant. It's not asking me this. It's not saying, hey, what's the least that it could possibly be? What's the lowest that it could possibly be? But I thought this would be worthwhile in my discussion of this question. Oh, and in case you don't know, you can do this if you can do like that sort of thing and pop it in. All right. So -23.73 repeating is less than or equal to f of 0, which is less than or equal to 20. Actually, I think we can just say less than, not even less than or equal to. But all right. -0.26 repeating. All right. So, yep, guaranteed negative. So use the Lagrange error bound on the value of, so there's our error bound. Therefore, f of 0 is less than 0. Yeah, because the most it could possibly be is negative. It's still negative, stuck being negative. All right, and keep going. All right, so I wrote y on these. Write the first 5 terms of the following sequences given a sub n. All right, so just in case you wanted to do these, I will do these. I'm not planning on putting this on the quiz, but this is it's a prerequisite skill for us to be able to do everything else. So a sub 1, we'll plug in a 1, and we get 1 over 2 minus 1, which is 1. And then plug in 2, and we get 2 over 4 minus 1 is 3. Then we get 3 over 6 minus 1 is 5. Then, all right, looks like I see the pattern. 4 is on top, 8 minus 1 is 7, then 5, and then 10 minus 1 is 9. And our next one, a sub n is equal to n plus cosine of n pi over 2. Oh, hooray. So when I plug in 1, I get cosine of pi over 2 is 0, so I get 1 plus 0, and I get 1. Then for the second one, we get a 2 here. I'm just gonna 2 plus 2 pi over 2 is negative 1. So it's gonna be 1 comma 1. Then let's see, our next one is 3 plus 0, so 1, 1, 3. Then 4 plus cosine of 4 pi over 2 is cosine of 2 pi, which is 1, so 5. Then 5 plus 5 pi over 2 that's going to be back to pi over 2, which is 0, so 5. Very odd sequence. Our next one, it says negative 1 to the n plus 1 times 2 over n factorial. So let's do the sign first. So if I plug in 1, I get maybe I was supposed to start with 0 for all these. Whatever. I'm going to start with 1. So we get, oh yeah, no. We started with 0 with Taylor series. With these, we did start with 1, because Taylor series had that 0 with derivative that we took care of. So I'm not sure if me turning my paper sideways is horribly disorienting or messes with people. I've been trying to ask for feedback, but I also don't want to know because I just want to keep doing what I'm doing. But if there's an issue, please let me know. So anyway, when we plug in 1, we get negative 1 squared, which is going to be positive 1. So it's going to alternate. It's going to be 1, or it's going to be positive, then it's going to be negative, then it's going to be positive, then it's going to be negative, then it's going to be positive. So then 2 over n factorial. So 2 over 1 factorial is 2. 2 over 2 factorial is 1. 2 over 3 factorial is 2 over 6. 2 over 4 factorial is 2 over 24. And then 2 over 120. You can simplify those. You can remove the pluses and minuses and make it look, or remove the pluses and make it look nicer, and yeah, whatever. All right, now let's get to the problems that are going to be tougher. Okay, write an expression for a sub n, the nth term of the following sequence. Okay, when it says write an expression, we want it to be explicit, not recursive. So here it looks like I'm adding 3 every time, so I can say 3n. And then if I think about that, if I just plugged in 1, I'd get 3, and I need to have 2 more. So it should be a sub n is equal to 3n plus 2. Let's see if that works. So with 2, we plug in 2, we get 6 plus 2 is 8. Plug in 3, we get 9 plus 2 is 11. Yep, cool, that works. All right, this next one, I see alternating from positive to negative. That's going to say that I want to have a negative 1. I'm guessing I'm going to want negative 1 to the n plus 1 or n minus 1. There's a lot of different ways that I could write that, but just some way. And I think Kevin was like, yeah, we could do cosine of n pi over 2 or n pi or something like that. Yeah, there's a lot of ways to handle this. So don't feel like if you wrote something different than me, you'd be wrong on that. So I'm just going to have that out front before I start thinking about this. So let's see. I do times 3. Then I do times 2. Then I do, nope, okay. Let's see. Let's see. Can I do an n times n? Let's see. Like, well, here it'd be minus 8 plus 18 minus 32 plus 50. So that's helpful. Now let's see if we ignore the sign. We get plus 4 plus 6 plus 8 plus 10. I think I found it. So every time I am tacking on 2 more, right? So that tells me that, well, what if I did n? So what if I did n times, what do I need to do this by? So n in this case is 1, then 2, then 3, then 4, then 5. I'd have to do times 2. Oh wait, no, we already talked about this, right? No, we didn't. I was thinking about this recursively. I was making this so much harder for myself. So 1 times 2 is 2, 2 times 3 is 3, 3 times 4 is 12, 4 times 5, here we go, 5 times 6. So I'm so glad that I didn't get this right at the beginning, and that took me a long time, because I don't want you to feel like, oh, if I don't get it immediately, I'm stupid. No, these things can take time. I'm sure that Harrison blinked and knew it, but, you know, which is awesome. I know it made that sound like it's somehow negative. So the only thing that, let's see, if I call this n, and then that's just n plus 1. So we're going to say this is n times n plus 1. And that's that. And then the only thing I need to do to kind of account for the positive, negative is then tack on the -1 to the n plus 1. So, tricky, kooky. All right. Oh, sweet. I saw the bottom immediately on this one, because I saw the 120 and I was like, wow, 120, that's really big. Oh, 24, hey, these are all factorial numbers. So we can say that we're gonna have n factorial on the bottom, and the top, 2, 4, 8, 12, those are all doubling. That's 2 to the n. So, oops, a sub n, there. Woo, that, okay. So, all right. Determine the convergence or divergence of the sequence with the following nth term, a sub n. Justify your answer. 2 points each, because it's a review paper. All right, so okay, hey, no, I'm still here. All right, so let me just find the limit as n goes to infinity. If we look at this as n goes to infinity, the 3 won't matter, the 3 won't matter because they're babies, the n's won't matter because there's n squareds here. All that's going to matter is we have n squared over 2n squared. That's a half. So it converges to 1/2. Oh, justify our answer. Okay, this isn't a justification. I would need to justify by saying the limit as n goes to infinity of a sub n is equal to 1/2. Therefore, it converges. Okay, there, it's done. So if we say, hey, here's the limit of the sequence, there. So in this case, little interesting. This out front, this diverges, right? It's bouncing back and forth between -1 and 1, -1 and 1, -1 and 1, -1 and 1. However, this guy, the top goes to infinity, the bottom goes to infinity. And I said in class, I was like, hey, just saying that, like, one's going to be more than the other, that's not necessarily enough. So let's think about this using L'Hopital's, because it's really infinity over infinity. So L'Hopital's says we can take the derivative of the top and bottom if it's infinity over infinity or 0 over 0. So we get 1 over n, which is equal to n. What's the limit as n goes to infinity? Infinity. So not only is it bouncing between -1 and 1, but it is also shooting off to infinity. So what's going to happen is it's going to be like, and get bigger and bigger and bigger, bigger. All right. Okay. So with this, if we were to just talk about n versus ln n, we know that the n is growing faster than ln n. So this would tend off to infinity even without using L'Hopital's, but it is helpful to say that. So since the limit as n goes to infinity of a sub n is equal to, it's not equal to infinity. It does not exist. It's not positive or negative infinity because it's bouncing between the two. So that means that a sub n diverges. All right, our next one. Okay, this is kind of strange. And a helpful way to look at this is to think about what cosine of 1 over infinity does. Because this is and it's called oscillating. Just like this last one was kind of bouncing, we call that oscillating. This is oscillating, so we over infinity. Here's the thing. We know that cosine of 1 over n, no matter what I plug in there, it's less than or equal to 1, and it's greater than or equal to -1. It's stuck between -1 and 1, bouncing back and forth between -1 and 1. So it's doing this sort of thing, but this is dragging those numbers down closer and closer and closer to 0. So that means that the limit as a sub n, the limit as n approaches infinity of a sub n is equal to 0. So it converges to 0. Okay, so this one's a not yet, but these two we can do. So I'm going to start with the seemingly simpler one because this one's already in its fraction form for us. So I'm going to rewrite this as the sum n equals 1 to infinity of something over n and then something over n plus 3. So to do that, we're going to do partial fraction decomposition where we cover up one of them. So in this case, I'm covering up the n plus 3. When I cover up the n plus 3, that gives me the numerator for this one. So I cover it up and I use its 0. The 0 for it is -3. So I get -1/3. And then likewise, we will cover up the n and plug in its 0, which is 0. So that's 1/3. So now we've got the sum from 1 to infinity of 1/3n minus 1/3n plus 9. So when I plug in 1, actually, another way to do this would just be to pull the third out at the very beginning. That might make life a little bit easier. A third out front, and it'd really just be 1/n and then 1/n plus 3. Yeah, that's going to go faster. So then we get 1/1 minus 1/4 plus 1/2 minus 1/5. So a fourth is where they're going to start canceling. Plus 1/3 minus 1 over 6 plus 1 over 4. And we know that everything from there on out is going to cancel. And if that doesn't make sense, write a few more terms out. You'll see that, oh, wait, every single one of these is canceling now. So a fourth is where they start canceling. So a fourth and more. So the fifth and the sixth. So we're going to get a third times 1 plus a half plus a third. So if I think about those as sixes, I have 6 sixes, 3 sixes, and 2 sixes. That's 11 sixes, so that's 11 ninths. So this one we're going to have to do some kind of messiness to figure out. Let's see. So we have n is 1, n is 2, n is 3, n is 4, n is 5. I'd have to do times 9, then times 3, then times 4/3. This isn't helpful. Let's try doing n starts at 2, 3, 4, 5, 6. Let's try that. 2 times 4.5. You know what? Maybe we haven't learned how to do this one yet. So I'm going to put a star by this, and we'll come back to this one because the strategies that we've looked at haven't applied to this yet. I believe this might fit into a category called an alternating series, which that's a little bit later. Okay. The last thing that we really need to look at here is for the following series, determine the possible convergence or definite divergence. For telescoping series, find the convergence. So remember that if the sequence converges, then it's possible that it converges. But if the sequence diverges, then it diverges. So here, if we look at the sequence, the n squared over e to the n, I get infinity over infinity, so I'm going to do L'Hopital's. So I get 2n over e to the n. Still infinity over infinity. L'Hopital's again, get 2 over e to the n. That's 2 over infinity. It goes to 0. So since the sequence converges to 0, possible. In case I did a bad job stating this, I'm going to say it one more time, that the only way it's possible to converge is if this is going to 0. If it's going to any other number, including like 0.1, it's too much, and it's going to definitely diverge. So here, 5/9 to the n. As this goes off to infinity, we want to see, is there any possibility for convergence? I'm going to pull the 4 out front since that's not affected. As long as this approaches 0, then there's a possibility for convergence. So that's 5 to the n over 9 to the n. That's infinity over infinity. It feels like that's going to 0, but let's just double check. So if I take the derivative of both of them, I get 5 to the n ln 5 over 9 to the n ln 9. Well, that wasn't very helpful, now was it? The derivatives don't really change anything. So I think it's safe to say that 9 to the n is going off to 0. So more on the fuzzier side of things, not on the super nailed down at this point in time, we can say that this is a possible converge. If we look at our next one, also, if you hear any high-pitched noises, Mr. Castellaneta is doing sound waves next door. So I'm not trying to mess with you with weird noises. All right, this one's a little strange, right? N to the 0.999. So n is less than 1 right now. So that means that we're doing like 1 over, we could think about this like this is 0.999 is 999 out of 1,000. So we can think about this as the 1,000th root of n to the 999th. It might not be helpful to actually think about it like that. But if we look at this and we try taking the derivatives, or like try thinking about what this is going to look like, 1 over n to the 1 gets bigger and bigger and bigger and bigger and bigger on the bottom. But, oh wait, no, yeah, this will get bigger and bigger and bigger on the bottom too. And it's just not as fast. Like 1 over the square root of n, that gets bigger on the bottom. It's just kind of slow. So this is a possible. I will tell you, this diverges, but we don't know that yet. If we look at our next one, 2 over n cubed minus 2 over n to the 4th. This one's a little bit harder to figure out. It's definitely a possible convergence because the limit does go to 0. Oh wait, yeah, no, it does, because each of these goes to 0 independently. So if we were to look at the first few terms of this, I'm going to pull a 2 out of everything and get 1 over n cubed minus 1 over n to the 4th. So I'll plug in 1 and I'll get 1 minus 1 plus 1 over 8 minus 1 over 16 plus 1 over 9 minus 1 over 81. Uh-oh. I'm not seeing things that are looking like they're going to cancel. So maybe this is not actually a telescoping sequence. I mean, telescoping series. So maybe I'm good. Maybe I don't actually have to finish the problem. Maybe all I can say is, it's possible. I don't know if you can hear that. All right, got to talk over the should I stay or should I go now. This is a possible. It's not a telescoping. This one looks like a telescoping by the denominators though. So I'm going to pull a 5 out of this one. 1 over n minus 1 over n plus 1. And let's plug numbers in. So we got 1 minus a half plus a half minus a third. Well, would you look at that? Plus a third minus a fourth. Guys, this is just going to 1. And then this last one here, the sequence is converging to 0, but we can't say any more than that, so we can say possible convergence. So all of these from our nth term test are possible, but they're not all going to actually converge, and we're going to learn more about that later. But I hope this was helpful, and yeah, the quiz will have some multiple choice and stuff like that on it, but I hope you don't bite the dust.